So in the previous lecture, we have seen the three terminologies which are host, IP addresses, and network. I'm just repeating once again, host are nothing but the devices which actually send or receive the traffic. It can be further divided or it can be further categorized into client and server. We have seen the client who actually initiate the request and server who actually respond. I further quote over here that client and server are the terminologies which are actually connection basis. Okay, so a server as of now who is actually server can be in a different communication can be act as client. As far as the IP addresses is concerned, IP addresses is nothing but identity of the each host, and it can be hierarchically assigned. It would be a 32-bit address and would be represented into dotted notation, and that would be 8-bit chunk of 4 octets. So then the next is the network. Network is nothing but what actually transport the traffic between the host. And as we discussed in the previous lecture that it is nothing but the logical grouping of the host which requires similar connectivity. For example, that you have the home Wi-Fi where all the devices which are connected to your home devices are actually uh, for the almost same purpose. So that's why they are grouped together. And the next we have seen the example of a university network where the different departments have their own subnetworks. So a network can be further divided into the subnetworks. So this is what we have discussed in the previous lecture. Now we will see the further network devices which are the repeater, hub, bridge, switch, router, gateway. All these terms we are going to see in this lecture. Now we will talk about the repeaters. So repeaters are nothing but the devices which actually regenerate the signals. यहाँ पे अगर हम देखें कि if there are two hosts which are at a distant location, अगर वो दूर हैं आपस में और यहाँ से सिग्नल ट्रेवल करता है तो धीरे धीरे क्या होगा बिकॉज ऑफ द डिस्टेंस दिस इज गोइंग टू बी एटीन्यूट. सो ये सिग्नल धीरे धीरे वीक पड़ने लगेगा और ये एक लिमिटेड डिस्टेंस को ही ट्रेवल कर पाएगा और उसके आगे की डिस्टेंस को वो ट्रेवल नहीं कर पाएगा. सो नाउ वी नीड अ डिवाइस to be attached in between that actually regenerate that signal, or you can say the amplification of that signal. तो यहाँ से अगर रिपीटर हमने बीच में अटैच किया है तो यहाँ पे अगर कोई सिग्नल वीक भी होगा तो वो वापस से जब यहाँ से निकलेगा तो फिर से वो रीजनरेट होकर निकलेगा. ओके, सो द रिपीटर actually allows communication across the greater distances. Now let's say we have seen as of now there were two hosts. Now let's add one more host. So let's say this is connected. Now let's say we have add one more host, then it must be connected to this and this both. Further, if we connect one more host, so उसको इससे भी कनेक्ट होना होगा, इससे भी कनेक्ट होना होगा और इससे भी कनेक्ट होना होगा. सिमिलरली एक और होस्ट अगर हम ऐड करते हैं यहाँ पे तो इस न्यू होस्ट को इस नेटवर्क से कनेक्ट होने के लिए इससे कनेक्ट होना होगा, इससे कनेक्ट होना होगा, इससे कनेक्ट होना होगा एंड इससे कनेक्ट होना होगा. ये आपका कनेक्टिविटी जो कहलाती है ये आपकी क्या है, टोपोलॉजीज हैं. देयर आर डिफरेंट डिफरेंट नेटवर्क टोपोलॉजीज. इस तरह की नेटवर्क टोपोलॉजी को हम मैश टोपोलॉजी कहते हैं. So, as of now, the topologies are not much concern for this lecture, but now you can see over here that there is a limitation in this topology, that if a new host comes, so उसको हर एक के साथ में connect होना होगा. Okay, so you can see that connecting hosts directly to each other doesn't scale. Okay, that means what I am trying to say is connecting hosts directly to each other doesn't scale. So that's why what we can do now, we can have a device in between which is connected to connected with all the hosts. So we can see now, if any further device is going to add to the network, it has to only connect to this hub. So this is the main advantage of hub. So now this device, we can write it as hub. So hubs are simply nothing but the multi-port repeaters. Why multi-port? Because there are multiple ports through which any host can connect to this hub. Now let's suppose this host wants to communicate to this, then it is going to send the packet to this hub, and now this hub is going to broadcast this packet to the all connected host to this device. So everyone receive everyone else data. So in case of hub, now because of let's say this is the limitation of hub, we can see over here, if a host 1 is simply want to communicate to host 2, then the data of host 1 is going to broadcast to the rest of host connected to this hub, and hence a new devices come into picture, which is bridge. So a bridge actually sits between hub connected host. So these are the hub, you can see these are the hubs, and bridge actually connects these hubs towards its left and to right. So bridge actually is nothing but actually you can write it, bridge sits between hub connected hosts. Bridge actually have only two ports. Now you can see that one towards its left and one towards its net right, left and right. Only two hubs can be connected, and through these hubs there can be a subnetwork and this can be another subnetwork. Bridge actually learns which host on each side. That means now bridge actually know the position of this host. Similarly, bridge knows the position of this host. That means bridge knows that this host comes towards the left side of the bridge, while this host is having position towards right side of the bridge. Now let's say if there is a let's say this host want to send the data to this host. In this case, this is going to send the data to the hub, and hub, as its nature, broadcast the packet. Once you can see over here that this one host number one has sent the data to hub, and hub has simply broadcast the packet. Now when the data comes to the bridge is going to see that through which address it is coming from, and it is coming from host 1. And just because bridge knows the position of host 1, that host 1 is having a position towards the left side of the bridge, then bridge is not going to send the packet towards its right side. So it will simply drop the packet over here, and the packets are not going to broadcast in the right side section of the bridge. But yes, towards its left, all the hosts are going to receive the packet. Similarly, towards its right, if these two hosts are communicating to each other, then bridge is going to stop the data coming towards from the right, and will stop the data to going towards its left. So now you can see that bridge actually learns the which hosts are on which side. Now the next device which comes, switches. Switches are nothing but a combination of hubs and bridges. So this is a switch, let's say, and you can see that as because it is a combination of hubs and bridges, so like hub it can connect to each host. So that means it is nothing but like hubs there are multiple ports, and so this is, you can say that switches are having multiple ports, And as because it is also having the functionality of bridges, that means it also have the functionality to learn which host are on which side, which hosts are on each port. So the thing is, you can see that switches are nothing but the combination of hubs and bridges. So now in this case, you can see if a host from this, let's say this is the host one and this is the host two. Let's say this host one wants to send the data to host two, and then means this host is going to send the data to the switch. And as because switch know the position of every host connected to each port, then switch is going to send the data to the dedicated host only. Okay, so that means if the data is coming from the one and that is intended for two, that means that switch is going to send the data only to the host number two and not going to broadcast the packet. So in this case, these are the, you know, these rest of the hosts are not going to receive that packet. So this is what the functionality of host. Now we can understand that switches basically facilitate the communication within a network. So this is an important thing that you can note down over here, that switches facilitate communication within a network, within a network. So switches facilitate the communication within a network. That means if a switch is connected through its multiple ports to the different hosts, let's say like this, then this group of hosts actually are nothing but going to serve the uh, similar connectivity or similar operation they have. So we can group these hosts together, and this group of as per the definition we have seen already, that this group is called your network, because you can see that group of these hosts require similar connectivity. So we can say that the group of these hosts are nothing but a network, where in between there is a switch which actually facilitate communication within the network. Here one thing you can note down then, that host on a network share the same IP address space. That is, for example, let's say if this network is having an IP address 192.168.1.x, so this can be dot 11, this can be dot 12, this can be dot 20, this can be dot 22, this can be dot 25, this can be dot 53, like this. Okay, so you can see that these all the hosts are sharing the same IP address space which is given to this network. Now, let's say if the host with IP address 192.168.1.222 is going to is want to communicate to this, then this is a communication which is called within the network. So you can understand there are two ways of communication in the computer network, which are: number one is the communication within the network and communication outside the network. So you can assume this network as your home Wi-Fi, as example we have seen already, where all the devices, yeah, you can see that this device can be your smart TV, this device can be your laptop, this device can be your mobile. So all the devices are having for the same purposes, and you can understand this network as your home Wi-Fi, or you can understand this network as your university network, where it is a network of particular department, let's say department 1. So you can assume that any of these example can fit in, okay, over here. Similarly, you can have like the XYZ company का जो example मैंने दिया था, so it can be specific office, let's say the London office of XYZ company, और उसका भी कोई एक specific department, let's say the marketing department. So इस तरह से ये कोई भी एक नेटवर्क हो सकते हैं, उनका अपना अपने आईपी एड्रेसेस हो सकते हैं, लेट्स से उसमें हमने जो एग्जांपल लिया था, इट कैन बी 10.30.55.x, इस तरह से। तो ये सब आपका यहाँ पे अंडरस्टैंडिंग आपकी बनती है कि स्विचेस किस तरीके से कनेक्ट होते हैं एक नेटवर्क के अंदर। The important thing to know is switches facilitate communication within a network, where network is nothing but the group of hosts which require similar connectivity. Now you may understand that further we have seen that there can be a communication within the network, or there can be a communication outside the network. For example, let's say if you take this example, what I have shown you in the previous slide, that this is the one network, and let's say I redraw this. So let's say it is, let's take an example of university, where there is one mathematics department and another one is biology department. So here are the switches. Let's say this is having 170.116.20.x, and there is another network which is having its IP address 172.16.30.x. Let's say this is dot 11 dot 22 dot 33 dot 44 dot 55 dot 66. So let's say you can see that this is one network which is connected to one switch, and all the hosts are here are connected to this switch one. And in this different network, let's say this is the mathematics department, network of mathematics department. This is the network of biology department. Now let's suppose if there is a communication between this host to this host, then that is going to be written in the network math network only. That means this machine 172.16.20.11, if it is want to communicate to 172.16.20.22, then it is going to send the data to the switch, and as because switch know the position of the receiving IP addresses receiving machine. Okay, and then it is directly going to send the data to that machine. But what if then that there is a communication, or you can say the host machine 1 wants to communicate to this host machine 6. In that case, you need another machine, another device which actually facilitate communication between the network, and that device is being called as a router. So you can say that router is a device that actually connects to networks. Okay, now this router can also be connected to the rest of internet. Now you can see that router is nothing but there are multiple NICs present over here. This NIC is connecting to this network. This NIC is connecting to another network, and similarly, the rest of the NICs are connected to different networks. So we can say that router facilitate communication between network. As because you can say that router is on the edge of the network. So let's say this is network 1. It is connected to this router. This is network 2. Okay, so you can see that as because the router is on the edge of the networks, so routers are the actual devices which can provide the traffic control policies, or you can say that it can implement we can implement the security here. We can apply the filter, or also we can apply the the redirecting can be done at this stage. So you can write it over here that router provides a traffic control point. We can assume that router to be a traffic control point. That is, we can apply the security, we can apply some filtering, also redirecting. Nowadays the new kind of switches are also coming where we can perform the filtering also, but traditionally switches could not perform any kind of filtering. Now routers also can learn which network they are actually attached to. That means you can see that through this interface, this is connected to this network 1. With this interface, router is connected to the network 2. So router actually know through which interface it is to which network it is actually connected to. And these this learning is known as the root of the router. And routing table actually having the information of all those routes. So these routes information are actually stored in the routing table. And routing table knows all the network a router is actually connected to, or you can say a router actually known about. So you can say let's say if this is a network with which a router is connected, this interface is connected with this network, then that every interface on the router which is connected to a network will have an IP address, its own IP address. Okay, so let's say if this was the network, so this can be an dot one. Let's say this is the switch. So let's say this was if dot 11 dot 22 dot 33, that then this interface will also have one IP address. Let's say it is dot 1 and this is dot 254. So every interface which is connected to a network will have its own IP address. And this is what we called as the default gateway. So फॉर एग्जांपल अगर इस नेटवर्क वन को डेटा सेंड करना है आगे किसी डिफरेंट नेटवर्क में, देन जस्ट बाय प्लेसिंग कि यहाँ पे जो आपकी नेक्स्ट इंफॉर्मेशन जो होगी, दैट मीन्स कि अगर यहाँ से आपको डॉट 11 से डेटा सेंड करना है, लेट्स से इट इज डॉट 66, इट इज 172.16.20.x सॉरी 20.11, ये मशीन अगर सेंड करना चाहती है डेटा टू 172.16.30.66 को, सो फर्स्ट ऑफ ऑल दिस डेटा needs to be sent to this interface of this router. Okay, and for that the router it should have the knowledge of this IP address, and this IP address is stored in the default is stored as a default gateway. So gateway is nothing but you can say that each host way out of from their local network. अगर कोई भी डेटा को उसके लोकल नेटवर्क से, दिस इज द लोकल नेटवर्क, अगर लोकल नेटवर्क से बाहर निकलना है, सो देन there would be a need of the gateway, and that gateway is nothing but the interface connected to that network, interface of this the router which is connected to that network. So you can say here the IP address, अगर किसी भी मशीन का आप वहाँ पे IPv4 की प्रॉपर्टीज देखेंगे या कॉन्फ़िगरेशन चेक करेंगे, so there would be three things in actual. One would be IP address, so let's say 172.16.20.33, let's say if I'm talking about this machine, and there would be a subnet mask. We will talk about the subnet mask later. Okay, that would be and then there is one more thing, that is default gateway. And default gateway would be the IP address of this interface, that is 172.16.20.1. Now when the host number 3 or you can say dot 33 wants to send the data to dot 66, it is first actually will send the data to this default gateway, or you can say to this interface, by getting the IP address from here. So this is what the actually router is. So I'm repeating once again that router facilitate communication between the network. Here you can note down that switches were facilitate communication within the network, while routers facilitate communication between networks. So in this case the राउटर की अगर हम इंटरफेस की बात करें तो वो सारे इंटरफेस आपका क्या करते हैं, वो एक आईपी एड्रेसेस रखते हैं जो कि उस नेटवर्क से होगा जिस नेटवर्क से वो इंटरफेस एक्चुअली कनेक्टेड होगा। ओके, सो उस इंटरफेस का भी अपना एक आईपी एड्रेस होगा, उसको हम क्या बोल देते हैं, गेटवे बोल देते हैं। और गेटवे आपका क्या है, द होस्ट वे आउट टू फ्रॉम देयर लोकल network. There is one more thing what we can understand here, that uh, routers actually create the hierarchy in the network or in the entire internet. So for example, let's say if I was talking about the XYZ company, it was 10.20 dot, let's say x dot x, and this is let's say the USA office of XYZ company. If I'm talking it, this is the sales department, this is marketing department, and this is production department. So let's say it is having IP address 10.20.55.x. This would be 10.20.66.x. This is 10.20.77.x. So here this XYZ company is having the IP address of kind 10.x.x.x. This is going to show about the New York office, or you can say the USA office. This is going to tell you about the department, which is sales department, marketing department, or production department. And this is what the actual host connected to this each department. Okay, so you can see that this IP address is nothing but the hierarchical address where you can find out the actual position of any host connected to the network. So let's say if these let's say if these departments altogether are having different their own unique IP addresses. So that means to connect this department with the other network, we need the router. So that is, one router would be connected over here, another router will be connected over here, and one router will be connected over here. And further, these routers are connected to a different routers. Similarly, this router is connected to this, the whole internet. Let's say this is another office, XYZ India office, which is having 10.40.x.x. This is the sales department, same marketing department, production department. This would be 10.40.55.x, 10.40.66.x, 10.40.77.x. Okay, so further this will be connected with the router, this will be connected with the router, this will be connected with the router. These all are connected with a different router, and this router is connected to the internet. Okay, that means there are, if there are two networks located at different location, then they are actually performing their own network, and those networks are connected through the router with the internet or with the rest of world. So you can see that there is a hierarchy in the network, or you can say in the entire network. So router is being routers are, you can see over here in the internet also there can be multiple routers. Okay, so this is, you can understand that this is nothing but a network of router. Okay, every network is connected through if it wants to connect to different network. Okay, then there should be a device which is a router in between. So router facilitate communication between network, whereas switches facilitate communication within the network. Routing is a process of moving data between network, and for that, router is a device whose primary purpose is routing. Similarly, switching is the process of moving data within a network. A switch is a device whose primary purpose is switching. So there are many other devices if you talk about that, those can be access point, layer 3 switches, firewall, load balancer, IPS, IDS, and proxies. In case of cloud, we can say that there can be virtual switches, virtual routers. So there are so many other network devices are also in the computer network, you can understand. But majorly, switches and routers are the main devices which are actually, you can say, the gist of the whole network. Okay, so here, whatever the rest of the devices what I named over here, all of them perform routing and switching. So this is where I rest my lecture over here, and in the next lecture we will see the OSI layer.